title of this is Source Science and the Hyperdimensional Nature of Reality. And I say that because we have used the term psychoenergetic science, spirited science, but I like the term source science because you can equate source with prana, God, mind. Source is like the creative part of the universe. So I like that term. And hyperdimensional nature of reality is anybody who believes or thinks that the universe is three-dimensional, they're caught in last century, okay? In fact, they're almost caught 2 centuries ago because quantum mechanics was invented over 100 years ago already. So realize that if you don't understand enough about quantum physics to realize that the nature of the reality is really hyperdimensional, then you really aren't watching enough Discovery Channel, okay? So I would encourage everybody to take what I have to say at heart here, because that's how the universe is constructed, and that's really how we're constructed as well, okay? And once you understand that, then humans become much more magical and magnificent than just meat machines, okay? So don't let the skeptics turn your thought process that, oh, we're just meat machines, because we're not. And in fact, as a computer architect who study neurology and mathematical neural models, is that they have no clue how the brain works. They have found some useful mathematical tricks that may emulate some of the mathematics that's happening in the brain, but they don't have a computer, and I'll show you later on, if you don't have a quantum computer and you're trying to simulate it, you can't do a very good job of that, okay? So that's fundamental to physics, and quantum physics in particular. So here's my bio. I started programming at the young age of when I was in high school, which was 45 years ago. And that was unusual in the late 60s. So I've been programming a long time. My mind is totally thought patterned around computing and thinking about computers. And in the early 70s, I was studying metaphysics, and I realized, well, everything I know about computers, everything I know about metaphysics didn't jive. In other words, that if metaphysics says that there's an information mechanism that classical physics can't explain, then I really am interested in that from a scientist and from a technology perspective. So to me, it's the next information age, and I've written papers about the next information age before as well. So, but as you can see, I even was the chairman of 2 conferences on physics and computing, where all these famous people who were in quantum computing showed up for these conferences. And I had some very famous people also show up there who were speakers, people like Ralph Landauer, who coined the term information is physical. Because of that, then I got a PhD in electrical engineering in quantum computing, and I've written so many papers. I'm saying 40, I don't know how many, more than that, and over 10 patents, and received actually $1 million of funding from the government to study neural and quantum computing, and they're related. So I've done a lot of useful things in Dallas, knowing that I'm sort of working on my own usually, and so it's fun to be able to talk to people about this, okay? So what is source science? I mean, the key is you have to understand a lot about modern physics in order to figure out what's going on. Turns out there's so much going on in modern physics. I mean, we always hear about the Higgs boson, right? The God particle and things like that, and the Large Hadron Collider. Think about how much money they spent on that, you know? Ultimately, the business needs to get, and the science needs to kind of work together to figure out how to fund these projects. And my goal is, by defining source science, is that it would make it okay for business people to start investing in this kind of information technology. So that's my long-term goal, is to get a job in this area, if you want to think about it that way. Think of it as my retirement plan, okay? So, but basically, there is a lot of physics and math associated with this. And that's why I call it quantum mind or quantum physics, because it sort of like says, okay, there's something different here, and we need to describe what it is, and we need to get people out of their traditional thinking about it. So I kind of come up with a catchphrase, quantum mind, as a way of talking about it, and now I'm using the term source science as a broader topic that includes quantum mind, okay? But I use the term source as generic for prana or life force or God, so that we realize that we're talking about something that is poorly defined, but what we do know about it says it's information technology. That's the good news, it's information technology. People have been talking about consciousness for 20 years. There's a biannual conference on consciousness in Arizona that's actually hosted by an anesthesiologist. He's interested in consciousness. Yeah, Roger Penrose and his colleague, the anesthesiologist. Roger Penrose is the physicist. And they're talking about consciousness for 20 years. I went to their first conference back in '94. But also thought, awareness, meaning, and knowing are as fundamental to consciousness, because you know that you know. You're aware that you're aware. You're conscious that you're conscious. All of those are self-reflective concepts that computers don't know that they're aware. They don't have an internal model about themselves. They're trying to be intelligent, and they're not general purpose enough to be able to do that either. So I want to work on real intelligence. I don't want to work on artificial intelligence. So I'm keeping track of neural computing stuff, but I don't really want to work in it because it's uninteresting to me, because it's not the real problem, okay? The mystery of human intelligence, it's not a meat computer. And, Google's been doing a lot with deep learning and deep mind and all that stuff and quantum computing, but nobody's come up with a general definition of what meaning is, meaning itself. And if we look at that chair, there's no meaning in the chair except we project the meaning of chair at the speed of thought. The chair has no intrinsic meaning. Any piece of data in the universe, any object in the universe, has no intrinsic meaning by itself. That's the biggest mystery is beyond consciousness, is how we do that. And computers have no clue on how to do that. The only meaning that's in there is if we see this pattern, then the programmer says, well, that means this. It's the computer programmer putting in the meaning. Usually it's not the computer itself. So there's a bunch of mysteries here, and I'm including psi in this, and you will see that I have no apologies for doing that. I use the term proto-physical because somehow quantum physics is more primitive than classical physics, and I'll have some slides about that later. Proto-physics means before physics. And when we think of physics, we actually mean space, time, matter, energy, fields, gravity. That's what we mean by physics, okay? And quantum physics and proto-physics, the physics of the Big Bang, it's what happened before the Big Bang that's as interesting to me as physics itself. And so I call that proto-physics, and that's more primitive and more fundamental, and it has to be information-oriented, as you'll see, than regular physics, okay? One useful thing is to think of, well, what is science? I mean, science is the study of physical things, but I say that source science is both physical and non-physical. And what I mean by physical is there's this dual meaning. Physical things are fields, matter, those kinds of things. And modern physics know that physics really means it's measurable and you can interact with it, right? But some things are really hard to measure. It's like neutrinos are really hard to measure. The Higgs boson, they had to build the biggest machine in the world to measure it, okay? You can't measure a quark. Nobody will ever measure a quark. It's unmeasurable. Okay, so does that mean it's not physics? Well, physics are kind of like, well, that's okay. We have a model for that, mathematical model for it. But you can't measure. You can measure its effect. Well, that's also what's true for black holes. You can't really see a black hole. You can just see its effect. You can't really see dark matter and dark energy. You can just see its effect. You can't really see a quark because you can't see its effect. You can't see love, but you can see its effect. So I think there's a bunch of things that fall into this category of physical things, things that you can measure, and non-physical things like quantum, thought, quarks, meaning, prana, love. Those are all things that probably are of the same ilk. You can't measure them. They're fundamentally immeasurable. Not measurable, but that doesn't mean they don't have an effect. So if they have an effect on the physical world, then by definition they exist, and we need to figure out how to do with that rather than ignoring them. So there's two famous sayings that I put here at the bottom. Richard Feynman says, the world is not classical, damn it, it's quantum mechanical. So stop thinking about the world as classical. It's an illusion that it's classical, it's quantum mechanical, and most people don't know what that means. I believe in 50 years from now, everybody will have a sense of quantum computing, just like everybody has a sense of your smartphone. Every 2-year-old has a sense of a smartphone, how to play games on it, what a car is, how it goes, what the transmission is, what the radio is in the car, how to roll the windows up and down. All of those things didn't exist 150 years ago. In 50 years from now, quantum mechanics will be ubiquitous, and you can see by that, by looking at the programming that the Discovery Channel has on, Spacetime PBS has on it. I signed up for that. There's so many great teaching facilities out there now that are all about this subject. You just have to go and be curious enough to listen to them. I'm amazed at the amount of resources that are trying to teach people about this. That, like I said, the PBS Space-Time channel is like, it comes right to my cell phone. I was watching it while I was getting ready in the morning when I was here. It's like amazing, all these resources out there. And it's fundamentally about these subjects, about the physics of nature of space and time, about quantum mechanics, about relativity, about all this stuff. So if you're curious about it, there's a lot of resources now that didn't even exist 5 years ago, okay? So that really, I would say that there's no distinction anymore between physical and non-physical as far as physics is concerned, because most of the things they're working on isn't measurable anyhow. So there's my spiel on that, okay? Classic physics emerges from the quantum realm, as it turns out, because quantum is more primitive due to these unusual properties. And I say most of the time when something was discovered, like the first twin slit experiment was done in 1800s, early 1800s, and they were still trying to figure out 100 years later. Okay, a lot of this metaphysics stuff has been around for thousands of years in many traditions. And they understood it, the physics, their instrument was the mind, you know, thousands of years ago in the Hindu and the yogi meditation and the yogi traditions, and all the sages of all times can tap into this directly. It's just Western physics thinks they have a lock on what's science, okay? So you have to just decide what's your instruments, and if your ultimate instrument is the mind itself, then you have to be able to be willing to listen to what the mind has to teach you. But quantum mechanics itself is like asking nature questions and then being willing to listen to the answer. And that's the surprising part, is even the founders of quantum mechanics didn't like the answer. They didn't like the answer because it was different than they expected when they went in. But you have to be able to listen to the answer that physics tells you. And that's an important concept, okay? And a lot of physicists, the modern ones, are doing that, and I applaud them. But there's a term, I'm going to only use this word once in this whole saying, skeptics. Skeptics are people say, oh, it doesn't exist, we don't want it, it's you know, you're lying, you're making up the data, whatever. I'm not even going to hardly give any attention to skeptics because they're doing a disservice to us, okay? So realize that you're going to get an answer you might not expect, but you have to be willing to listen to the answer that physics gives you. So, and here's the kinds of things that physics tells you, that everything's quantized, and there's this particle wave duality. And you have things like, you think, okay, we have spin, okay, great. We have charge, great. Oops, there's spin 1/2, not spin 1, spin 1/2, and charge 1/3. Well, what does that mean? It's discrete, but it's in 1/3 increments? What does that mean? So realize it's quantized, and sometimes your quantization breaks down even, but it's still discrete. Speed of causality is really based on quantized energy, which gives rise to the speed of light. I only read that on one of these Spacetime PBS channels the other day. It's not speed of light the limit. Speed of light comes from the quantized nature of causality. Speed of causality is the thing, and that's related to relativity. So these are advanced concepts. Most people don't have the math. I don't have the math for it. So you have to kind of understand it at an intuitive level and then use it to your advantage. For example, most people don't realize that most people don't think that relativity affects their life at all. But every day they have to adjust the satellite times because up in orbit, those satellites have a slightly faster clock than we do on Earth, and they get out of synchronized. And it's because of the laws of gravity that we're running in a different time frame, and so they have to keep adjusting the clocks. And in fact, up there, even all the receivers have to be tuned a little bit different because of the frequencies because of that. So realize something as simple as relativity affects our lives in a modern world because we're so finely attuned to all this technology. They have atomic clocks now that are so sensitive that you can take two of them side by side and they're synchronized. You raise one by a foot and they run at a different rate due to gravity. And they can detect that. So just realize we're that far along in technology so we can directly see the effects of this stuff, okay? Quantum measurement and the wave collapse. You know, that people always say, well, you have to have, in order to have wave collapse, you have to have a human in it. Well, that's trying to put metaphysics back into physics, so, but more of a philosophy then. So there's this whole question about collapse of the wave function. And again, these are all quantum physics concepts. The uncertainty principle, it just says, think of it as you can vote in the Republican primary or the Democratic primary, but you can't vote in both. And so if you're more Republican, then you can't vote in Republican in the Democrat, okay? And so that's the same kind of idea, is if you're trying to measure your distance, you know, where your location is, but you want to measure a momentum, you can only pick one or the other so accurately. You can't arbitrarily pick the accuracy of both. And it's a pretty strong argument to understand why that works. So superposition of states, you know, you can have half heads and half tails. What does that mean? Probabilities are fundamental in physics. And I'll have a slide later on about probabilities. Entanglement so freaked out Einstein, he called it spooky action at a distance, trying to disown it, you know, trying to make sure that nobody would work on it. But he was wrong. Bell proved it in the 60s that entanglement is real, it exists, it violates what we know about relativity, and it's real, and they're using it in technology now for quantum key distribution. They routinely build quantum entangled systems in the lab, and they're using them for quantum cryptography and quantum communication. So, and all the experiments they're doing with entanglement's also related to that. Tunneling. We use tunneling for all of our transistors and semiconductors and stuff like that. That's all related to quantum probabilities, and quantum probabilities isn't a wave. We think about waves, we think about fields, we talk about all these different kinds of fields. A quantum probability is an abstract mathematical concept that has a point in space, and if you square it's a probability. That's why tunneling works, because the probability on the other side of this well is non-zero. There's actually no wave there. It doesn't actually go through, it's just the probability exists over there, and so it shows up there at times. Well, and it's non-local. It doesn't dissipate with distance. It's not a field. It doesn't dissipate with distance, 1 over square of distance, you know. It's like all the other fields do. So realize that our language once in a while gets, and we're going to have a slide on language too. So superconductivity, Bose-Einstein statistics. I only read a really good article about Bose-Einstein statistics, so I'll talk about that more in later. But the biggest one is bits are physical, and they're the smallest increment in the black hole. These are the two strongest arguments. Bits are no longer part of computer science. They're part of physics. And they're fundamental to the measure of entropy, which shows up as the surface area of the black hole. The units are bits. And the smallest change to the black hole you can make is a bit. So if you throw a bit in the black hole, that's the smallest change you can make. So that means it's a bit bucket. All the matter and energy from that sun that went into the black hole is now on the surface area as bits. So it's a big bit bucket and a bit blender. And so realize that a black hole is a computer. It's just got all the bits stored on its surface area. It's also a hyperdimensional bit bucket, because if you take a high dimensional space, imagine each bit being its own dimension. They're all like pushed together, but they don't want to be together, so they're far apart away as they can, and they're all on the surface area. So the inside of the black hole is a singularity. If you do the math on that, which Claude Shannon was in Dallas in the 80s, and he talked about this, if you have a hyperdimensional space and you compute the ratio of the surface area to the volume, as you increase the number of dimensions, you find that all the volume of the sphere, hyperdimensional sphere, is on its surface area. So you don't even need gravity to do this. You can just do mathematics with this, how we compute volume versus surface area. So realize it's all on the surface area of a black hole for two reasons, not just one, but it all has to do with hyperdimensional math. Each one of these is a deep subject. I'm just trying to give you a sense that this is the learning curve that you have to go through if you're really curious like I am, and I've studied virtually all of these, and I've met some of the people who are working in this as well. Shor's algorithm is another particular one. 1994, the guy created not only a new algorithm for a quantum computer, but it showed that there's a new complexity class. You can't create complexity classes every day, mathematical complexity classes. He showed that if you have a quantum algorithm running on a quantum computer, you can solve a problem in linear time, polynomial time, that cannot be solved with any other classical computer. It can only be solved that way with a quantum computer. That means it says quantum computers are exponentially more powerful than classical computers. Well, if humans tapped into that, we would have a much higher rate of survival. And in fact, I believe we do. That we are quantum computers, and the fact that we've survived as a species, in fact, all biology tapped into it somehow, that even single-cell creatures tap into it somehow, through microtubules, or that's the theory, is that through microtubules. Stuart Hamroff is the guy I was trying to remember, the anesthesiologist. And they basically show that single-cell creatures are the size of a neuron, and yet they are intelligent. So how do they do it? With microtubules. So intelligence builds up, and it can start very small, and it builds up to the level that we are, and I believe that it can go way beyond the intelligence that we are, and that's what we would call supermind and genius and those kinds of ideas. So realize that all of this is from the quantum realm, and it's all stuff that you can't explain it in classical physics. This is all quantum stuff, and you can't ignore it anymore. There's way too much to ignore. Okay? And there's a really good book out there called Spooky Action at a Distance. That's the name of the book. It's written by a Scientific American author. And I read it, and it basically comes to the same conclusion. He says, if you don't know about entanglement, you don't know that space and time is an illusion, then you're caught in last century again. So realize, and another important thing, so you can't get purely quantum behaviors from any classical physics. You just can't. You think you can simulate them, but you can't simulate them effectively. In fact, the most efficient way to simulate a quantum system is to use a quantum system. So that's why they're trying to come up with general-purpose quantum computers, and that's why Google is working with a quantum computer from the Vancouver Quantum Computing Company, because they're trying to use a quantum computer as an analog quantum computer to do computing, because that's the fastest way to do it. if you can coax it into doing the problem. So the other thing that's driving me is I've experienced transpersonal stories, and there's a bunch of transpersonal stories out there. And the notable ones, these are just some notable ones, everybody has their favorite. I'm always surprised when I'm talking to people about, well, have you read this book or this book and this book? And I've not heard of any of them. So realize that everybody has their own clique of books that they like to read, and it's good to share them, because some of them are outstanding, okay? But telepathy is real. I know several groups of people that it's part of their business plan to use telepathy. Okay, so sink in. Telepathy is real, and if we're not using it, we're kind of missing the boat. And so there's people using it out there. Susie Miller, the third one is a particular one. She has this program called Awesomism, and instead of, she works with autistic kids, and she calls it Awesomism instead of autistic. She calls it Awesomism, and these kids are actually advanced, intelligent, supermind beings who don't interact well with the physical world. And it's because they're so sensitive that they don't interact with the physical world. And so she can interact with them telepathically and teaches their parents to do so, and the kids are much better off. And she's so good at this telepathy that her whole organization uses telepathy in their group, okay, such to the point that now the telepathy that they are interacting with has turned into a spoken language built on telepathy. And I would call that a light language. And you can go to Susie Miller YouTube videos, and you can hear her talking this. Think of it as sounding like something from Star Trek, where they're showing Klingon, which was an invented language that an alien would speak. This is actually not a human language. Okay, I call it a light language. So realize there's some interesting things out there. You just have to be willing to open your mind and say, I wish I knew that language. I would love to learn that language. I think that would be a cool language to learn. Also, there's a woman named Esther Hicks who's the leader in law of attraction. She's not the only one. The people who did the movie The Secret studied her first, had her in it. Then they wanted her to sign her rights away to release the movie, so she says, no, I've been doing this first. So they edited her out of the movie. And she was the leader in law of attraction, and other people too, even before The Secret. But the movie, The Secret, came out, and the book, and it was really popular because Oprah pushed it on her show, and so she had a big following. Also, I've personally chatted with four-leaf clovers. I went to a meditation camp for a week, and during that time I talked with four-leaf clovers, and they talked back. And as you can see, this picture here this is my slide here of spoons, and all the spoons and forks I've been to, in all the workshops I've been in. That's my little, and this one here in the middle here is totally curlicued. I don't know if you can see that very well. Right here, this one is a total curlicue right there. So anyhow, the point is the mind can interact with the physical reality. So believe that. So how does it show up in your life? Well, me, it showed up the first time I bent a spoon. I did it like every time I've done spoon bending, I've succeeded. And when I've taught people to do this, usually several people in the class do it too instantly. And kids do it, love it. They do it instantly too. Kids do it. So realize that this stuff works. Also, these are my heroes. Robert Monroe, Journeys Out of the Body. He was an out-of-body. In fact, at his Monroe Institute is when I talked to four-leaf clovers. That tells you that he's a fundamental hero. There's this new book relatively recently. The woman has already passed away in the last couple of years since it was published. It's called Extraordinary Knowing. She kept saying, if this is true, this changes everything. And she was talking about the fact that somebody who was doing dowsing, to help her find something, and they found it for her. And then she was just shocked that it really worked, and that it was able to find this thing, a very expensive thing that somebody had stolen. And so realized that these particular books are particularly interesting because they're so well written. Okay, Journeys Out of the Bodies is a classic. Mind Reach is a classic. U.S. government study of remote viewing. Joel McMoneagle is one of the people in the Mind Reach program. Patricia Cyrus is a personal friend of mine that I met at the Monroe Institute. She's a world-class remote viewer. And Randy Zeisness, he's a hero of mine and relatively recently, and he's a friend of Bill Tiller's as well. These two books on NDEs are very good. They're both relatively new. Anita Moorjani, she's actually an Indian descent. She's got Indian parents and she's Indian, but she was cured of stage 4 lymphoma cancer after an NDE. She had no cancer in her body after a month, after an NDE. So, and of course, there's all the prana generators: Reiki, acupuncture, pranic healing, Kundalini. There's a device called Intention Host Device by Bill Tiller and Randy. They are the inventors of this. And also structured water. Randy is working in structured water. Tony Wood is a friend of mine from Dallas who invented structured water for his own patent. He sold it to a company, Revolucio, in Tacoma, Washington. They raised $60 million funding to do biowater. $60 million. So that's the kind of talking that we're talking about, looking at building industries around this technology. And things like Buddha relics. There are actually tours of the Buddha relics, and this particular friend, Nisha, she's a friend of Bill Tiller's as well, and she's been personally paying for the Buddha relic tour around the US, so she's involved with it, and she has some amazing stories for that. So those are some, this slide here says, once you realize transpersonal stories are everywhere, and in fact, I say, if you can touch the divine, it's life-changing. When I talked to four-leaf clovers, it was life-changing for me. Okay? So if you haven't had a touching the divine experience, seek it out, because it will increase your humanity. Okay? So that's cool. So I always talk about thoughts on thoughts. I like to think about thoughts. Okay? Thoughts is a technology. It's like thinking about bits or computer programs. They're non-classical requirements. If you know telepathy is real, then it means something from an information perspective. What does it mean? It represents a symbolic meaning without language. Because you don't have language. You have the meaning, and a lot of these transpersonal experiences, they have experiences they can't express in language. So it's meaning before language. And it's hard to express in language. It's the same thing as a child. They know everything about their world up to 1 year old, but yet they don't have words associated with it. The words is the last label they attach to the meaning that they already have in there. So realize that. Also a friend of mine, Deborah, she's a healer in Dallas. Also a friend of Bill Tiller. Bill Tiller has a lot of friends. And she is a healer, but she's also a telepath. And she was talking to me one time, we were talking about telepathy, and she said, Doug, you have parentheses around all your thoughts. And I go, really? And it turns out I programmed in Lisp for 10 years. And Lisps are notorious for putting parentheses around everything. Well, after 10 years, I just naturally do that in my mind for every thought. I'm putting parentheses around my thoughts. How would she know that I did that unless she was telling me this very personal experience that she was able to talk about? And she said, that's very unusual. Well, most people who are telepaths who I interact with always say that I'm unusual the way I think. So, hey, I'm used to that. Okay. So telepathy is important because it has meaning. It's information technology. Okay? And humans can directly affect the physical world. These are all the PK experiments, non-local and psychokinesis. Okay? I'm going to show a couple of these. This is the intentional host device. This is the one Bill Tiller did with Randy. And basically, it's a small electronic device that if you meditate with it, you can set an intent in it, and then you can put it somewhere else, and you can measure the effect of that intent. He measured it where he took water, and the intent was to either lower the pH of water by 1 degree or increase the water pH by 1 degree. By the way, one number in pH is 10 times either acidic or basic. It's a Richter scale kind of thing. And so he could set this in the laboratory experiment, let it run, and the pH of the water would go like this or up with the intention. Well, how does it know the difference between up and down? Because you have an intention there, okay? And so he invented this technology. And we haven't only begun to touch the surface of this. Okay? You could use this for all kinds of things. Like, they're using this technology with the awesomeism people. You can sign up to be in the study, and that means that they show your name on a screen with this machine running next to it, and you receive the intent from this machine, and then the awesomeism kids get better. They show better because they're part of the study. Non-local intention on the internet. It's amazing the kind of technology that's out there, that if we would just put as much money as we did at Large Hadron Collider as we did with this stuff, okay? The twin slit experiment, I'll show that on a slide. The remote staring experiment, the copper wall experiment. They put a meditator in a room, have the walls and ceilings all suspended, electrically isolated copper walls. The meditator sits there, electrically isolated chair, and pretty soon there's 200 volts. No current, but there's 200 volts on these walls. They've structured this field of the room enough. They're not generating electric field, but the net effect of it, there's a voltage on these copper walls. So again, as all these experiments, I know tons of people who blow out light bulbs every time they come in a room. They go and start to use a computer, it dies. Their microwaves die all the time. Their clocks die all the time. Their watches, their cameras. They're a noise disaster for electronics. Well, these people are actually changing the quantum mechanical properties of the transistors and shorting them out such that then they break. They're fused. And so the fact that humans can affect, there's a slide there in a minute showing that humans can affect the quantum mechanical properties. So essentially humans are noise to quantum states. When we're trying to build these ultra-sensitive machines, I'm just going to have fun with them sometime and go start mucking with their machines and changing their data on them and see what they do. And the point is you can do it. There's nothing to keep you from doing it, okay? There's all kinds of things like this. So the other one is timelessness. There's precognition, retrocausation, delayed choice. Delayed choice is quantum physics. Precognition, these are all well-defined experiments that they've done, and I'll show you a slide on that. So thoughts are things, but people have been saying thoughts are things because they change the world. But if you think the thought is in the brain, then they say, well, it's a thing in the brain. But I say, no, thoughts are really quantum things. In fact, I have another hour talk I gave, Thoughts are Quantum Things. It's an MP3 file out there on my website. So you can hear what I've already said about that if you want more. But it's probably made of these hyperdimensional bits, and we'll talk about that as we go. So here's the best one. This is the most recent one I like. This is by Dean Radin. He did 2 experiments where he said, a meditator relaxing on an interferometer, which is a twin slit experiment, and you get the wave nature because each particle goes through both slits, and you get this wave interaction. And if you want to read more about this, there is a Dr. Quantum animated video about twin slit, and it's Fred Alan Wolf as Dr. Quantum. It's animated videos. Again, more YouTube videos for you to listen to. And so what happens is you can say relax, and you get the normal quantum twin slit experiment results like this. Okay? Then if they say concentrate on this, what they're doing is putting the mind's eye and they're collapsing the wave function with their intention. And it changes the probability distribution. This isn't an enclosed box. This is a totally enclosed, sealed box. And their mind is reaching in and changing the probability amplitude of the twin slit experiment. As if somebody is doing a measurement here and stopping the flow of this thing here. This is a great experiment because the only thing that's there is the property of the light and the intention and focus. That's it. And they've done this both locally and they've done this on the internet. And they've done thousands of trials. And he's been busy working on this for the last 10 years. Go look at Dean Radin's YouTube videos about this. And in fact, all random event generators can be influenced by PK, even mechanical random event generators. They have mechanical cascades. And the first time I tried the mechanical cascade, it was all skewed. You would think you wouldn't be able to affect mechanical cascades, but you can affect all probability stuff because essentially you're injecting order into the system. That's entropy. Your mind can directly affect the world because thoughts inject information in the world which shows up as entropy, which shows up as change in the statistics. So even mechanical cascades, which the Princeton Engineering Lab did that since the 80s. Robert John, who's the Dean of Engineering at Princeton in the 80s, he got private funding to go study this, and he wrote an article in IEEE magazine in like 1981 showing that, parapsychology is a neat scientific area to go study. He was my hero because he said, oh yeah, I should go study that, after reading that article. And realized sometimes the effect size that you're looking for the measurement is actually slightly in the future. They can correlate it with the intent and the effect, and they're finding out it's actually in the future. And so there's a whole bunch of... I could talk for an hour just on time effects. Non-local time, precognitive. And I have one slide on that. So here's my one slide on precognitive remote viewing. A friend of mine, Patricia, Cyrus, I met her at the Monroe Institute, and she did an experiment with me one time. She had a dream. And the dream says, Doug, this saying came up. She says, invariant phase shifting. And it was directly related to the quantum computing work I was doing, because I was doing something having to do with phase shifting. Okay? So I didn't know what that meant, though. So I didn't tell her, and I said, let's do a remote viewing experiment. She's done over 250 controlled remote viewing experiments with 95% hit rates by third-party judges. Okay? She's very good at it. And we like to talk to each other, which is kind of fun, so I get to hear inner thoughts about this. And so I wrote this on a piece of paper, and that's the actual what I wrote, put it on an envelope in my bed in Dallas, and she's in Florida. And I says, it's going to be there at 8 o'clock on Saturday night, and she does a remote viewing, and I said, describe the appearance, purpose, mechanism of the device using invariant phase shifting. So the first thing she draws is the picture up on the right here, which is this device, and she says that it looks like a slide with bacteria and the light, and it looks like there's emanations coming out of it like this, and thin and flat. But if you realize that the mind talks in modalities and submodalities, which is an NLP term. NLP says, you know about lines, you know about swirls. Those are submodalities of vision. Those are the primitives of language of the mind, is submodalities and modalities. That's how we organize things in the mind, okay? But the word she put there was her interpretation of it. So the point is, what's interesting about this device on the picture on the right here, even though this started out as a dream, and then she drew this image, this is exactly the same dream image that I had when I was working on a device that would be in an electronic brain that we could use high-gain PK device, and I expected it to be a semiconductor that our mind was talking to. She drew a perfect picture of that. That's the exact image I have in my mind. But we're talking about the life force, so she thought it was biology. So she tapped into all the elements of it, she just labeled it wrong. So realize that if you have something you can't express in words, because it's symbolic, and then you try to express it in the words, you're putting your own meaning in on it. So you have to try to express it as fundamental elements as you can, symbolic, metaphoric elements as you can first, before you put the meaning in, because it will send you in the wrong direction. This is a fundamental to dreaming and dream interpretation, is to realize your mind does not speak in language. It's not language, it's metaphoric. Okay, so this is important. But what's interesting is that this happened in 2005. The other picture she drew was this building. Well, in 2008, I was trying to build that device with a company that was in this building in 2008. Look at the picture. It's an exact artist sketch of the building that I was working to build this device 3 years later. So this is a personal, precognitive, remote viewing experience with me. Okay? You'd be surprised what you get when you ask the question. So don't be afraid to ask the questions. Hey, we're scientists. Should we apologize for the fact that we're working on source or psi? And I say no, because in the past, shamans from every society and era were their scientists, essentially, right? But my heroes are the Robert Monroes, the Robert John, the Bill Tiller, the Dean Radin, the Daryl Beam, who is the guy who did the retrocausation stuff. And also, you got to realize, as a scientist, you have a hard problem, because you have unstated assumptions that you have that might affect the models, like the nature of space-time itself, the nature of mind itself. If you don't account for that in your description, then you're going to have it wrong. You're going to have a false assumption, like assuming that it's a wave when it's a particle or vice versa. And then out-of-time behaviors, because you break the causal models, okay? The scientist's beliefs can affect the results, because it's a classical particle-wave duality. Scientist attention can affect the results. Just the placebo effect alone requires blinding in order to affect this. So it becomes almost impossible for scientists to do this job, because they have to do all these safeguards to do good science. But basically, anybody who's doing pharmaceutical research has to do the exact same thing, because they have to show that their drug is at least as good as placebo effect anymore. You can't produce a drug that's only as good as the placebo effect. If it's any better than that, you have no drug. You're just paying attention to it solves it. You know. So if you have a doctor who's caring, that might alone be enough to heal you. You know, or a nurse, or whoever, caretaker is. But the key thing, quantum mechanics show the incompleteness of classical physics, and humans exhibit these behaviors that you can't just support with classical models. And information is physical, we've already said that, and so we want to include mind and metaphysics in that, just because if you don't, again, you're making all these assumptions about the nature of space-time and mind. And the universe is quantum mechanical, damn it. You know, it's hyperdimensional and has bits in it. And so I use the term protophysics, and remember, subjectivity is part of this. And so skeptics don't determine the law of physics, God does. That's my quote. I invented that one, so I like that one. These are some of the things that the sages of the ages, as I like to say, have been saying about human consciousness. Consciousness, awareness, meaning, knowing, attention, intention, of being. Just being rather than doing or any kind of action. And so the mind is the source of all of this. In fact, think of it, if the mind has visual impressions in a dream and or out in an out-of-body experience or a near-death experience, and you're not in your brain, that means that your mind itself has a representation for visual phenomena. So then it's a chicken and egg problem. Since it was in the mind first, the body was developed by the mind to give you an interface to be able to use that. Rather than we're visual because we have eyes. Well, we didn't used to have eyes. So how can we develop such complex biological systems by chance? By Darwin's chance? No, I don't believe it. So anyhow, but once you realize they're primitive to the mind itself, then you realize, oh, it kind of flips the story on the other side. And also I said the mind is probabilistic, it's gestalt-oriented, and it has these archetypes or symbols. Also, the mind can focus at any level, subatomic to galactic level awareness. This is an image of an Anu, which is actually Indian Theosophical Society. Last time I gave the talk here, there were some people from the Theosophical Society. This is, if you use your mind like a microscope, you can get to the quark level in atoms, and there's a book out there called Occult Chemistry, PDF, out there, you search for it. You can get it free on the internet. It talks all about the Theosophical Societies, Annie Besant and Leadbetter. And it was in the early 1900s. This was before the periodic table was well known. And they were describing the atomic weights of all of the elements using their mind as an atomic, and they were describing this thing here that looks like a quark. They were just in combinations of 3. And they're basically saying, if this is like a quark, if this is a quark-like, it's 10-dimensional. And then they come in 3 pairs of 3. There's 10 bands on here. It's like a little ball of yarn. So I've been working on high-dimensional math, and I've up to 5 dimensions already. So if I can get to a 10-dimensional model that can describe an Anu, I would like to know how to do that. So that's kind of interesting. And by the way, they say the number of dimensions in the universe that are more like our dimensions rather than these tiny little bit dimensions is like 12, which comes from the metaphysical world. There's also 12 auric fields, and there's 12 chakras, which is related to that. So the mind, because it can focus anywhere, it's non-physical. I call it the universal source code. The mind is the source code of the operating system of the universe. Source science, source code. It goes hand in hand, okay? And so let's start meta-programming our universe, is the way I look at it. The mind is massively parallel, and it has no limit to complexity. If you build a computer to solve an exponential problem, let's say I want to solve a problem, there's 2 sides to this. It's an exponential problem which grows so big. So let's say I want to solve it in a certain period of time. So then I have to build this number of steps, and each little computer has a step in it, and I have to put all those pieces of the computer in a ball the size of something that's the radius of the light cone that I want to compute the unit time in. So I build a computer of that size and put that number of elements in it, and they each have an effective mass, and you can show that that mass in that volume exceeds the black hole limit. So some exponential problems you can't solve in a short period of time because you can't physically build the computer, it exceeds the black hole limit. If you then use a fixed size computer, trying to solve it with a fixed space parameter instead of a fixed time parameter, and then you try to build it, then it runs beyond the length of the universe. It'll take longer than the length of the universe to solve it. So it doesn't fit in the universe that way either. But yet Shor's algorithm is an example of a quantum computing algorithm that you can solve in linear time, and it fits in the universe, but it's using all those dimensions that aren't in the universe. They're not in the physical universe. It cheats. It uses all those extra dimensions as a computational resource. And Shor's algorithm then solves the problem that can't be solved by a classical computer because it's cheating. Okay? Which is a clever cheating, not a bad cheating, okay? You can't have any complexity limit, and because we have to solve the problem of genius and supergenius. How do we do that, okay? So you have to have a representation, and I'm talking about representation in a minute here, where you can have arbitrary complexity limit, with no complexity limit, arbitrary complexity. And people talk about everything's divine, and everything's intelligent, everything can interact and respond. And that's part of the transpersonal experience. And we need to understand how that's possible, too. So people say we are more than a physical body. We're magnificent spiritual beings. And here I'm an engineer talking about these things. And the goal is we have to have source science to help explain this stuff, these mysteries, okay? Next slide. So here's some characteristics. Hopefully you see that this is a lot of technology. And that if you're not curious about any of these pieces, that hopefully I'm inspiring you to be curious about them, okay? But if you know anything about humans, you know what I'm saying is true. And so we have to kind of say, well, what are we have a problem to solve. This computer called human mind. Okay, and human, us. It's like any other technological problem. We have to understand the requirements, okay? So what are some of the characteristics about this? So I'm approaching this as an engineer, but I'm a human trying to experience this. So it's information. It's not a wave. It's not a field. It's neither matter nor energy. It's an infinite supply, because obviously Shor's algorithm uses a whole bunch of dimensions, and that's an infinite of those. And I'm telling you, when I'm saying infinite, Shor's algorithm, a 1,000-bit quantum computer, has 2 to the 1,000th states, simultaneous states. 2 to the 1,000th. 2 to the 300th is the upper limit on the number of molecules in the known universe. So you have more states in that quantum computer, that's the size of a pinhead, than the size of the number of elements, atoms in the known universe. So you can see when I'm saying infinite, I mean infinite. We have a hard time understanding infinity, so realize that that's part of the puzzle. Is when I say there's no complexity limit, I mean no complexity limit. It's infinite. How can you have infinity? Okay, so that's part of it. Okay, and I think that these little filaments, we're going to call them bits here. Gee, I wonder why we should call them bits, but they're bits where they're showing up as little filaments, little light filaments. These source filaments, you can observe them with the mind's eye. This photo I have here is an artist rendition, high quality. This one isn't particularly high quality, but they have high quality. It's from Deborah, the person who saw my parentheses. She's a healer. She sees auras. She tried to draw the highest quality pictures she could of the aura. So this is her vision of it. She says that sometimes she'll have somebody who's sick and one of the chakras isn't the right color, and she'll coax that chakra back to be the right color, and that heals them. So it's when you can see this kind of stuff, there's all kinds of, the observer is the ultimate instrument, you know, like you were seeing the Anu. Well, medical technology, we could certainly use people more like that. I mean, my chiropractor in Dallas, I walk in and she walks up to me, she says, "Does that hurt right there?" And she touches something, and she knows that it hurts, and I'm unaware of it, and she touches it, and I'm going, "Yeah, that's sore. How did you know that?" I wasn't even aware of it. She can just see it, and she knows it, okay? So realize that there are people out there like this. They're doing good, and they hide from people who can't explain it because they'll get ridiculed. So realize that, you know, we have all these protection of different groups. At some point there's going to be a law. I don't know how soon it will be. There will be a law that says you cannot discriminate somebody against it based on their metaphysical powers. Because if you do, one person I know is a remote viewer. He uses remote viewing to find a piece of equipment. This guy, Randy, he got fired from his job because they couldn't explain how he knew where this was, because he used remote viewing to do it. They figured he cheated and mailed it there so he'd make himself look good. So realize that this is the kind of things that happen when people are in fear. Okay? We can mechanically generate the source. I worked with a physicist who figured out how to mechanically generate chi, life force. And my description of it is all you have to do is tug on the ether. All the technology is doing something where it's tugging on the ether, and we'll talk about that. You can encode this in air, water, churches, temples. So these are all the characteristics. Hyper-awareness and direct knowing is a really important one. Anything, anywhere, any when. And you've all heard it, where attention goes, prana flows. We need to explain that, you know. Some people call it the Akka chords, and that when you're paying attention to somebody, you connect with them with Akka chords for the Akashic records. These are all the characteristics. I think people are enamored with modern technology because it turns out it's a metaphor for the mind's abilities. Intelligence is ubiquitous and everything can interact. Well, that's the definition of Internet of Things. You know, everything is on the internet. You can interact with everything on the internet. Well, that's sort of what these people are saying, is this metaphoric thing. We are all connected as if space and distance does not exist. Well, that's the internet too. And there's sort of a oneness because of that. Well, sort of. Not quite the oneness that you have over there. But, you know, and Google search and Wikipedia are like direct asking and knowing, the Akashic records. Tweets and alerts are like little intuition, little thought packets. When they do remote viewing, they actually put the request out to say, I intend this target, and comes back this thing that Robert Monroe calls a rote. He was an engineer, he liked to come up with terms. He called it a rote. And we think of it as a rote as an internet packet of the mind. And they get this little thought packet back, and then they have to unencode it. It's outside of time, and they have to turn it into language. So this is that symbolic thing that they're talking about. These little rotes come all the time, and sometimes we ignore them. But if you pay attention when, oh, that thought's from outside, pay attention to those. And usually, I'm a little slow sometimes. Usually, when it shows up the third time, then I pay attention. The second time I go, aha, somebody's trying to send a message to me. And the third time it shows up, I say, okay, I'll take action. But I realize that they will show up, and they're little thought packets that come from outside you. And that's important to pay attention to those. We call it intuition. So you can call it what you want. But digital video recorders, they replay and they do slow motion. It's like warping time. Virtual reality and gaming are like lucid dreaming. Video calling, sonograms, medical scanners, satellites are all like remote viewing. Tweets, email, social media is like sharing, like rotes and telepathy. Telepresence and drone, 3D video goggles are like astral projection. 3D printer technology is like direct manifestation. Medical technology is like innate healing. So I came up with this metaphor one time, and I'm going, no wonder this technology is so compelling to us, because it's mimicking what we can naturally do with our mind, but we haven't learned, we still are barely remembering we can do this with our mind, and so we're trying to build an artificial version of what we naturally can do. So here's some of the requirements. We've been collecting requirements so far. We must identify a thought information representation that does not depend on matter and energy. It transcends space and time, and any derived space and time properties like frequency. So people always talk about vibration and frequency. There is no frequency in the metaphysical world. Sorry. There is a state, and it shows up in our physical world like frequency. But in that domain, there's no frequency because there's no time and there's no distance. Frequency requires time and distance to measure it. It's a derived property based on space and time. So if you get rid of the space-time metrics, you get rid of all of classical physics metrics, including energy, and most of the things that we think about as physical properties that we assume, take for granted are there. None of that's there. I say it has to be Turing complete. It can compute anything. I say it has to be quantum computing complete. It has to be consistent, holistic, probabilistic, and entangled. It has to be Shor complete. It supports Shor's algorithm, which implies hyperdimensional nature. Entangled also suggests high-dimensional nature. I say it has to be von Neumann balanced. Von Neumann is the architecture where they had the program and the data in the same memory, and then they could write programs that they could modify the data. And so von Neumann architecture is what our computers are today, okay? The problem is you can't take any data and turn it into a program. But in the quantum world, every state is both a verb and a noun. It's both the data and the program. It's perfectly von Neumann balanced. It's a verb noun. And that way it can self-evolve. If you have all this data out there that isn't part of the program, then you're not the source code. So because space and time are separated, we see them as separate. We see the data part and the program part, the change. You know, they're both data to start with, but some data is executable. But regular mathematics for quantum computing has the same problem. They use matrices. They have a representation that says, here's the column vector for the state. But to do an operator on it, they need a matrix. This matrix and this column vector are different representations. In fact, I can show you a representation that I used for my PhD, geometric algebra, where that doesn't use matrices, but it's just as powerful as matrices, okay? And you can show that every state is also an operator. And when you do it that way, you find out that it's verb-noun balanced. Notice I'm putting the verb first instead of noun-verb balance. I'm putting verb-noun balance because we're so noun-dominated, I want to get us to switch out of noun dominance in our language. Our language is noun dominant. Native American Indian languages are verb balanced. They can string verbs together, and it's like in quantum computing to take all the operators and apply them all together and get this super operator, which is the combination of all those verbs. So a verb-dominated language like an American Native Indian language They think about problems differently because their thought patterns have structured their thinking differently because of their language. So that's part of that whole thing. So then you can have self-organization in spite of entropy. In fact, because of this, we think that the mind may be a source of negative entropy. And I can show you, using information principles, how you can generate energy. And that's one of the slides in a minute here. The other thing you want to be able to have is robust, probably probabilistic interaction with the mind. And that's what we see in these PK devices. They're random event generators. Everything is arbitrarily interconnected. Usually when you say that, people think, oh, it's a hologram. But the problem is with hologram is a dimensional reduction tool. And it's reversible. But because you can generate the hologramic image, you can generate the original image. But it is not Turing complete. You can't do arbitrary computation with a hologram. It's just a way of reducing the representation. So having an actual high-dimensional space can't be reduced by a hologram. You can't reduce entangled spaces using a hologram. Holographic is a nice metaphor, but it doesn't help you solve the problem of consciousness. And quantum states meets most of these requirements when you use some explanation into it. Let's clean up our language. First of all, you can't talk about dimensions, because in space-time we have all these little tiny dimensions, a little string, little bits. We'll show you a picture of that in a minute. And that's these little primitive dimensions. They're not full extent spaces like we have here, just little prime dimensions, and they're little constraints, little constraint systems. That's what these bits are. There is no frequency, there's no Fourier transforms, so I only use the term vibration, I never use the term frequency. Never use the term fields or waves, because there's no space, there's no frequency, and there's no propagation of fields. EM or gravity. Energy, it's a well-defined term in physics, but there is no energy in this domain. There's only bits and complexity measures. And you can probably use a metric similar to an energy metric, but you wouldn't call it energy. Subtle energy is a category area. I prefer the term source or prana. We don't call energy subtle mass, so why should we call prana subtle energy? Let's come up with our own term for that. Anytime you catch yourself using any of the terms, slap yourself on the hand or wherever, and stop yourself from doing that, because the words you use affect your thinking. This is NLP 101, right? NLP 101 is, if you see somebody speaking, it reflects how they're thinking. So if you want to change the way you speak, change the way you think, and vice versa. This is NLP 101, okay? And I also say it has von Neumann computing. It's not verb-noun balance. So you have to have everything be both the data and the program, okay? Which means that if everything is more a verb than a noun, everything is active instead of passive, because it's not just static, then that responds why everything looks intelligent over there. Because everything is active. Everything is more verb dominance, verb-noun balance, as I call it. So the things, other language terms to be avoided for high-dimensional spaces, distance. There is no distance. It turns out you can use the exact same formula for Euclidean distance, and we call that a similarity or a correlation. But you don't use the term distance about that. It's not a distance. There is no distance. You ask, what's the diameter of a black hole? You can compute its circumference. And normally the diameter is pi times that, right? But the diameter of the black hole is always 0, because it's a singularity. Space is totally contracted. The entire inside is on its surface area. There is no space-time in there. If you ever hear anybody say, oh, we're going toward the middle of the black hole, you know they have it wrong. They haven't included relativity. The inside of a black hole is a single point. The diameter of a black hole is 0. Period. So if you think anything else, you're thinking about it wrong and you're talking about it wrong. So you can identify who's not thought about it deep enough by what they say. And there's some really famous people out there who use this kind of language all the time, these language problems. So I'm a 5-year NLP master practitioner, and this stuff bugs the crap out of me, so excuse my French. Please, please, please help clean up our thinking by cleaning up our language, and vice versa. There is no duration. There's only change. Things happen, there's change, but there is no global time. There is no relativistic time. You can have a dream at night that felt like it lasted years or a lifetime. It has to do with the number of bit events that you occurred. No time has physically passed. our time is totally emergent from primitive change in that world, and that they're completely independent. So you can't talk about duration. Non-local, there is no distance. So something local in 4 dimensions appears non-local in 3 dimensions. So if you're using the term non-local, it's because you're assuming it's in 3 dimensions. Well, that's pretty much an indication that you're wrong, because it's probably 4-dimensional or 5-dimensional. Faster than light, same thing. It's the same problem with if you take the back door, then an instantaneous, and so they say Bell's theorem and entanglement is 10,000 times faster than the speed of light. Well, if you measured something that was 1,000,000 times longer, it would be 1,000,000 times faster, because it's instantaneous. So whatever metric you use, it's instantaneous. So don't talk about faster than light. It's instantaneous because it's through a separate dimension. They think of them as local to that additional dimension. For example, if you have a 2-dimensional space, you're a flat world. There's a good Dr. Quantum out there at Flat World. You can go, and everything was flat. You can't take a rope that's sitting there. You can't make a knot with it, because you have no dimension to put it loop on itself. So a 2-dimensional world has no knots. It's hard to do biology without knots, okay? So if you have a 3-dimensional world, you can do a knot, because you have the 3rd dimension to top it. If you now take that knot and move it into 4 dimension, you can immediately pull apart, because there's another dimension to let it escape from. So knots only exist in 3 dimensions, and if you're in 4 dimensions, knots don't exist. 2 dimensions, they can't exist. So the number of dimensions that you have in your reality is totally dependent on what the structure and the topologies that you have. So just realize that non-local is because of the dimensionality, and I'm telling you, the universe is hyperdimensional. So stop talking about non-local, because for some of those dimensions it is local. Like I said, here's the one I said earlier, the center of the black hole, the diameter is exactly 0. Somehow complexity increases without using energy. So we need to understand that. And again, holography. Go to next video.